Hello everyone! Sa discussion na to, magpo-provide tayo ng additional examples dun sa natitira nating convergence test for series of non-negative terms, which is limit comparison test. And we will also give some exercises on alternating series test. Before we proceed, it is highly recommended that you watch the lecture video first. But if you are already familiar with limit comparison test and alternating series test, then let's do a quick recall bago natin silipin yung mga exercises natin for this discussion. So sa limit comparison test, we have two series of positive terms, an and bn. And if we take the limit as n approaches infinity ng an over bn, tapos nakuha natin ay positive real number, then both series should converge or both series should diverge. On the other hand, if yung nakuha nating limit ay 0 and yung pinang-divide nating series is convergent, then yung nasa taas na series should converge as well. Lastly, kapag yung limit natin equal sa positive infinity and yung pinang-divide nating series diverges, then yung nasa taas would diverge as well. If wala sa tatlong to yung na-solve mong case, then limit comparison test is inconclusive. So you either change yung series that you are using as comparison or use another test. Okay? So next, we have the alternating series test. So applicable lang to, as the name suggests, sa mga alternating series. So kung wari, meron tayong alternating series of this form, tapos yung bn natin, nakukuha natin kapag tinanggal natin yung nagpapa-alternate sa series, which is in this case, no, negative 1 raised to n or n minus 1. Tapos if positive yung bn natin, kunin natin yung sequence bn. If it is ultimately decreasing and yung limit ni bn ay equal sa 0, then yung series nagko-converge. Okay? So ngayon na na-refresh na tayo about our topic, let's proceed with looking at our exercises. So ito yung mga exercises na gagawin natin sa discussion na to. We're asked to determine whether the following series are convergent or divergent using either limit comparison test or alternating series test. It is highly recommended that you pause the video first and try this on your own muna bago nyo tignan yung solution na ibibigay ko. Without further ado, let's start with our exercise 1. Here we have the sum from 3 to infinity ni ln n over n. If napanood nyo yung previous discussion, this series is known to diverge via integral test and comparison test. So this time, i-apply natin yung LCT. Hindi natin ma-apply si AST kasi this is not an alternating series. So, i-try natin yung limit comparison test instead. So maghanap tayo ng series to compare this with. Ano yung gagamitin natin? Well, try na muna natin yung ginamit natin last time, which is 1 over n. Kasi the same with comparison test, yung limit comparison test, we tend to look for a series of comparison dun sa mismong an natin. And in this case, try natin si 1 over n, which is a divergent series. Okay? Now, iset natin si an to be our ln n over n, tapos si bn to be 1 over n. Tapos kukunin natin si limit ni an over bn. Tapos, that's just equal to ln n over n times n. Kinuha ko na kaagad yung reciprocal ni bn, tapos minultiply siya sa an. So magkakancel out lang yung n natin, leaving us with limit as n approaches infinity ni ln n, which we know to be positive infinity. So we have that positive infinity yung limit ng ratio. Tapos, meron tayong divergent na series sa denominator, which is just case 3 ng LCT, and therefore we can conclude na yung original series natin also diverges. Indeed, ito yung sagot na nakuha natin previously. So, for exercise 2, Still, nakita na natin to from previous discussion, which is a convergent series via integral test and comparison test. Apply natin si LCT, and since we know na convergent to, try natin then ulit si 1 over n squared. So, we will compare it with this convergent P series. Tapos, we set an to be this, no? Tapos si Bn, siya yung 1 over n squared natin. Kukunin lang natin si limit as n approaches infinity nung ratio ni an at bn. Tapos, magiging siyang ganito. Again, magka-cancel out si n squared. So, ang matitira mo ay limit as n approaches infinity ni sine 1 over n. But 1 over n as n approaches infinity ay 0. So, this is just sine 0, which is 0. So, meron tayong 0 na limit, tapos convergent na series for comparison. So, case 2 yon ng limit comparison test, and we can conclude that our series indeed converges. Okay, so exercise 3 na tayo. Sa exercise 3, we are given the sum from 1 to infinity ni n plus 3 raised to n over n plus 2 raised to n, which we know to diverge via comparison test. So let's use limit comparison test this time, and let's use the same series for comparison, 3 halves raised to n, which is a divergent geometric series. So we set an to be this and bn to be our geometric series. So kunin natin yung limit as n approaches infinity ni an over bn. This time meron kang a bit more complicated limit, pero kaya natin to. So, i-distribute ko muna tong 2 raised to n dito sa numerator, tas yung 3 raised to n sa denominator, which will give us 2 raised to n times n plus 6 raised to n all over 3 raised to n over n plus 6 raised to n. And if you remember from Math 21, anong ginagawa natin dito? Dinidivide natin siya sa pinakamalaking a raised to n. So, this time, i-divide natin both numerator and denominator by 6 raised to n. That will give us n over 3 raised to n plus 1 all over n over 2 raised to n plus 1. So, paano natin i-compute yung limit na to? Pwedeng i-compute natin separately yung sa numerator and sa denominator muna. Tapos, if they exist, then yung limit ay yung ratio ng dalawang yon. So, ano yung limit ni n over 3 raised to n? Pwede tayo mag-L'Hopital's kasi infinity over infinity lang to. So, magkakaroon tayo ng 1 over 3 raised to n ln 3, which since nasa denominator na lang yung may variable and it approaches infinity, then this becomes 0. And under a similar idea, yung limit as n approaches infinity ni n over 2 raised to n equal din sa 0. So, yung original limit natin would just be limit nung taas over limit nung baba, which will give us 0 plus 1 over 0 plus 1, which is equal to 1. Hence, yung limit natin na 1 ay isa lamang positive real number. And since yung series natin for comparison diverges, we can conclude via LCT na yung original series natin indeed diverges. So, pare-pareho yung mga nakuha natin and dapat pare-pareho talaga. So, let's move on to exercise 4. This time, we're given the sum from 1 to infinity ni sine 1 over n, and hindi pa natin to natry before, so wala tayong idea if convergent ba siya or divergent. But since yung nakikita lang natin na familiar series within an is 1 over n, perhaps let's try the route na nagda-diverge siya. So, piliin natin si 1 over n as our series for comparison. So, we let an to be sine 1 over n, tas yung bn natin ay yung divergent series nating 1 over n, no? Tapos, we take the limit as n approaches infinity ni an over bn, which is just the limit as n approaches infinity ni sine 1 over n over 1 over n. And note, no, as n approaches infinity, si 1 over n nagiging 0. So, we can transform this into limit as u approaches infinity, ni-sign u over u, where u ay actually just 1 over n, no? So this will become 1. Or if you don't remember this fundamental limit from our Math 21, then pwede ka namang mag-L'Hopital's rule dito and you will get an answer as well. So, since meron tayong limit na nasa positive real numbers, and nagda-diverge yung series for comparison natin, then our original series should diverge as well. Okay? So, sa exercise 5 na tayo. For exercise 5, we're given the sum from 2 to infinity ni 1 over n plus ln n. Hindi natin gagamitin si AST kasi hindi to alternating series. Yung nakikita ko lang na familiar series dito ay 1 over n, no? So, subukan muna natin yon. We compare it with this harmonic series. And in fact, pwedeng gawin mong 2 to and this is still a divergent series, no? So we let an to be 1 over n plus ln n and bn to be 1 over n. And kukunin natin ulit yung limit ni an over bn, which is just n over n plus ln n as n approaches infinity, no? Since si n pumupuntang infinity, si n plus ln n pupunta din yung infinity, meron tayong infinity over infinity, applicable si LHR. So, L'Hopital's rule, i-differentiate natin yung taas-baba. So, meron kang 1 over 1 plus 1 over n, which we can further simplify into, dapat n to ha, n over n plus 1. And since pareho yung degree ng numerator and denominator, as n approaches infinity, ang makukuha mo dito ay ratio lamang ng coefficients ng leading terms, which is 1. So, nagkaroon tayo ulit ng limit na nasa positive real numbers. And since yung kino-compare nating series ay divergent, we can conclude that our original series also diverges by limit comparison test. Okay? So, sa exercise 6, meron tayong sum from 1 to infinity ni negative 1 raised to n plus 1 times ln n over square root ni n. And this is an alternating series, so we might as well apply alternating series test. So yung una natin gagawin ay isa-set natin yung bn natin, which is just taking out yung alternate nung sign ng ating an. So, tatanggalin lang natin si negative 1 raised to n plus 1 and that will be our bn. Tapos, ito, isa-set ko lang si f of x to be equal sa ln x over square root of x para si f of n equals sa b of n. And I'm just doing this to prove na yung sequence bn ay decreasing kasi kapag kinuha mo yung f prime of x, makukuha mo tong equation na to, which we can further simplify into this. And kapag finactor out ko si square root of x sa taas, and i-cancel ko siya with the denominator, ang matitira sa akin ay 2 minus ln x over 2 times x raised to 3 halves. And remember, si ln x, nag-i-increase siya, tapos si 2 is a fixed constant. So, at some point, ma-overtake ni ln x si 2. And that happens whenever x is greater than or equal to 8. And that's okay kahit hindi siya nag-i-start sa 1 kasi we only want sa alternating series test na ultimately decreasing si sequence bn. That is, at some point, magiging na siyang decreasing. Okay lang kahit yung first few terms ng sequence mo ay hindi decreasing. So we can conclude na si sequence bn is ultimately decreasing. Okay? So, na-prove na natin na ultimately decreasing siya. We just need to prove na yung limit ni bn as n approaches infinity ay 0. So, let's compute that. Yung limit na to ay magbibigay sa atin ng infinity over infinity. So, by L'Hopital's rule, magiging lang siyang equal sa limit ni 1 over n over negative 1 over 2 square root of n, which we can simplify into negative 2 over square root of n. And since nag-increase without bounds yung denominator while fixed yung numerator, then this is just equal to 0. And na-satisfy na natin lahat ng conditions ng alternating series test, we can already conclude na yung ating original series is convergent by AST. Okay? So, sa alternating series test, wala tayong conclusion na nagda-diverge. It's just for convergence ng alternating series. For divergence, wala. Okay? Sa exercise 7, we're given the sum from 1 to infinity ng rational function na to. And since hindi siya alternating series, magle-limit comparison test tayo. And since kailangan natin maghanap ng series to compare this with, ano yung possible na piliin natin? Well, medyo fixed kapag rational functions, no? Sobrang useful ng LCT for these cases. Kasi you can always just get the ratio ng leading term ng numerator sa leading term ng denominator. Pwedeng tanggalin na muna natin yung mga coefficients. So, kumwari, meron kang n cube over n raised to 7, which will give you the P series na 1 over n to the 4. Kasi, anong mangyayari kapag yun yung ginamit mo? Kapag yun yung ginamit mo, meron kang an equal dun sa rational function natin, tapos yung bn natin ay equals sa 1 over n to the 4. So kapag kinuha mo yung limit, parang magmumultiply sa numerator ng n to the 4. So magpapareho na yung degree ng numerator mo and denominator, giving you this. So alam natin na kapag kinukuha natin yung limit as n approaches infinity ng isang rational function, tapos magkapareho lang yung degree nila, kukunin lang natin yung ratio between their coefficients. So, meron tayong 3. So, madali siya. And it will work every time. Kapag mas malaki yung degree nito, ipapareho mo lang siya and you'll arrive at a real number na positive, no? So, since meron tayong case 1 ulit, no? Meron ka limit na positive and nagko-converge yung series for comparison natin, then we can conclude that our original series also converges. Okay? So, sa exercise 8, we are given the sum from 1 to infinity ni square root ni 2n minus 1 over n. So, anong gagamitin nating series for comparison? Well, pwede mong i-apply yung logic na ginamit natin sa exercise 7. I think magwo-work yung square root of n, no? 1 over square root of n. So, try that. Pero, gamitin natin dito yung 1 over n kasi para mag-cancel out lang siya, no? So, if isa-set natin yung series for comparison natin to be the harmonic series, isa-set natin si an to be ito. Tapos si bn yung 1 over n natin. Now, kapag kinuha natin yung limit ni an over bn as n approaches infinity, magka-cancel out lang yung n and yung matitira natin is limit as n approaches infinity ni square root of 2n minus 1, which we know to become infinity. So, it increases without bounds. So, ang ating limit ay equal sa infinity and we're comparing with a divergent series and therefore, by limit comparison test, nagda-diverge din yung ating original series. Okay? So, sa exercise 9, we're given the sum n from 1 to infinity ni cosine n pi over square root ni 2n minus 1. So, anong gagawin natin dito? Hindi natin magagamit si limit comparison test kasi si limit comparison test ay for positive terms lang. And remember na si cosine n pi, nagbibigay siya ng negative values depende sa n, no? So, i-note natin na matratransform mo itong an natin into negative 1 raised to n over square root of 2n minus 1, which is an alternating series. So, i-apply natin si alternating series test. We let bn to be 1 over square root of 2n minus 1, which is positive, no, for our n greater than or equal to 1. Tapos, isa-set ko lang tong f of x to be this para mas madaling i-prove na decreasing si sequence bn kasi kapag kinuha mo si f prime, ang makukuha mo ay ito, which is less than or equal to 0 for x greater than or equal to 1. Therefore, si bn, sequence bn natin, ultimately decreasing. So, kailangan na lang natin yung limit ay equal to 0. So, yung limit as n approaches infinity ni 1 over square root of 2n minus 1 ay equal sa 0 kaagad. Bakit? Kasi yung nag-increase lang naman na yung denominator. So, mag-0 lang yan. Palaki ng palaki yung denominator. Hence, na-satisfy natin yung lahat ng condition for alternating series test. We can already conclude na itong original series natin ay convergent by alternating series test. Okay? So, sa exercise 10 na tayo, we're given the sum from 1 to infinity ni 1 over n squared cosine ni 1 over n, which is similar dun sa isa nating exercise, just that cosine to, pero yon ay sine. So, try natin, no, na i-compare siya with 1 over n squared. So, i-try natin to. Kung i-compare natin siya dyan, yung an natin would be this, no? Tapos, yung bn natin ay 1 over n squared. So, kapag kinuha natin yung limit, magka-cancel out lang yung dalawang n squared, which leaves us with limit as n approaches infinity ni cosine 1 over n, but 1 over n as n approaches infinity ay 0. So, meron kang cosine ni 0, which we know to be 1, which is a positive real number, and nagko-compare tayo with a convergent series, and therefore, by limit comparison test, yung original series natin, nagko-converge din. Okay? So, on to the second to the last exercise na tayo, exercise 11, we are given the sum from 1 to infinity ni 1 over cosine squared n plus cube root ni n. Since this is not an alternating series test, gagamitin natin yung limit comparison test. So, ano yung pipiliin nating series to compare these two? Well, hanapin natin siya sa an, no? Pwede natin sigurong gamitin tong 1 over cube root of n since kasi alam natin yon ay isang divergent na p-series. So, kung kukunin natin yung limit after setting an to be this and bn to be 1 over cube root of n, yung limit natin, kailangan natin mag-squeeze theorem kasi meron tayong cosine squared n, no? So, paano tayo ulit mag-squeeze theorem? Kailangan muna nating i-bound tong an over bn natin. Ang an over bn natin dito is just this an multiplied by cube root of n, no? So, meron tayong alam na bound for cosine squared n, which is 0 to 1. Tapos, pag nag-add tayo sa lahat ng terms ng cube root of n, we'll get this inequality. And we can just get the reciprocal. Tapos, finally, magmumultiply lang tayo ng cube root of n. And positive yon, so hindi magbabago yung direction ng ating inequality. So finally, nabound na natin si an over bn with these two functions. So kukunin natin yung limit ng dalawang to. And alam natin na yung limit ni 1 as n approaches infinity ay still 1. And likewise, yung limit natin as n approaches infinity ng cube root of n over 1 plus cube root of n ay also 1. So, since yung bound natin ay parehong may limit na 1, then mapo-force tong quantity na to na maging 1 yung limit. And 1 is a positive real number. So, yun yung case 1 ulit ng limit comparison test. So, since yung series na kino-compare natin diverges, we can conclude by limit comparison test na yung original series natin diverges as well. Okay? So, sa last exercise natin, similar lang siya sa exercise 11, just that yung cube root of n natin, magiging siyang cube root of n to the fifth. So, pwede nating i-apply yung previous logic, no? Makukuha mo yung same thing kapag finalo mo yung process na yon, just that, ano yung magbabago? Well, so kukunin natin pa rin yung series na to. Tapos, isi-set natin si an to be this. Tapos, yung bn natin, nagilang siyang 1 over cube root ni n to the fifth. So, kapag kinuha mo via squeeze theorem, yung magbabago lang sa inequalities, yung cube root of n, dapat may to the fifth to, okay? So, magigilang talagang yung mga cube root of n natin, naging cube root of n raised to 5 lang. So, na-bound pa rin natin yung ating an over bn. So, kukunin natin yung limit. And yung limit, same thing, 1. Kasi, no, ratio lang to nung leading terms. So, since yung limit ng mga bounds niya ay 1, mafo-force yung nasa gitnang function natin to be to have the limit 1 din. So, since si 1 ay isang positive real number, and this time yung kino-compare nating series ay nagko-converge, no? We can we can we can conclude by limit comparison test na yung original series natin nagko-converge din. That is case 1 kasi ng limit comparison test. Okay? So, in fact, no, since magagawa natin yun all the time, itong process na to, kung yung babaguhin lang natin dito sa AN ay yung power ni N, then dependent lang dun sa power na yun kung ano yung kung magiging convergent or divergent yung series natin. Okay? So, indeed, ito ay nagko-converge. Whereas yung sa exercise 11, nagda-diverge. Okay? And this serves as the last exercise for this discussion. Thank you for watching this video and I hope marami kayong natutunan.